In this video, we're going to solve quadratics using the quadratic formula. This is a different method to solving quadratics. This is the method that we're going to use if quadratics aren't easily factorable. If you can factor it quickly, then you should factor it because that is faster. All right, but every now and then you're going to come across a quadratic which is difficult to factor, therefore we have this method. And the quadratic formula is in the upper right hand corner. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sing it to the tune Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's a bunch of different mnemonics out there to help you out, but this is the formula you have to know if you want to use it with your quadratics. Okay? Most of the ones that we'll come across can be factored. Okay, but every now and then, like I said, you're going to come across that tough one. So like this one, 2x squared minus 5x equals 12. We still have to set our quadratic equal to 0 before we can use the quadratic formula. From there, I like to identify what's my a value, what's my b value, what's my c value. Okay? Because once you identify your a value, your b value, your c value, it just involves plugging in to the quadratic formula. X equals negative b. So that's going to be negative 5. Whenever I substitute in, I always put it in parentheses. I highly recommend you do the same. So x equals negative 5 plus or minus the square root of b squared, so in parentheses negative 5 squared, minus 4 times a, which is 2, times c, which is negative 12, all over 2a, and a is 2. Okay? So what I'm going to do now is I'm going to just start simplifying. So I've got x equals negative 5, which is 5, plus or minus the square root. Negative 5 in parentheses squared, that's positive 25. And then negative 4 times 2 times negative 12. That's going to give me positive 96 all over 2 times 2, which is 4. All right, so then just one more simplifying. I'm going to simplify what's underneath the radical. 25 plus 96 is going to give me 121 all over 4. Okay? From here, square root of 121, I know what the square root of 121 is. So I'm going to go up here, and I'm going to simplify that. Square root of 121 is 11. So x is equal to 5 plus or minus 11 all over 4. Okay? So then I'm going to split this off into 5 plus 11 all over 4. And x equals 5 minus 11 all over 4. Okay? So that's going to be, for my first one, 16 divided by 4. So x is equal to 4 there. And then over here, 5 minus 11 is negative 6. So negative 6 divided by 4. That would either give you negative 3 halves, or if you do a decimal, negative 1.5. Okay, so that is how the quadratic formula works. Let's do another one. X squared plus 18x minus 243 equals 0. Already said equal to 0, so I can list the a value, the b value, and the c value. The a value is 1. There's a 1 in front of that x squared. The b value is 18. The c value is negative 243. All right, so next I just plug into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so now I'm going to simplify what's underneath the square root. I'm just going to plug what's underneath the square root. I'm not going to include the square root, but I'm going to plug what's underneath the square root into my calculator. Make sure you're careful with those parentheses. And I'm going to get 1296 over 2. Next step that I usually do with the quadratic formula is see, is what's underneath the square root. Can that simplify nicely? And it can. The square root of 1296 is 36. So from here, I'm going to split this off because I have x equals negative 18 plus 36 over 2, and x equals negative 18 minus 36 all over 2. So after simplifying those, x could equal 9, or x could equal negative 27. So because those are nice numbers, x equals 9 and x equals negative 27, I could have factored this. This would have factored into x minus 9 times x plus 27 is equal to 0. But you might not be super familiar with what multiplies to 243 and adds to give you 18. Or sorry, multiplies to negative 243 and adds to give you 18. So that's why this quadratic formula exists. It is a little bit more work and it's easy to make minor mistakes. But if something's not easy to factor, then we have this to fall back on. All right, last one. 5x squared minus x plus 8 equals 11x squared minus 20x plus 18. Got to set it equal to 0. And I want to keep my a value positive still. I like a nice a value. So I'm going to subtract everything from the right-hand side, or sorry, rights and lefts, from the left-hand side over to the right-hand side. So that's going to wipe out the left-hand side and leave me with 0. The right-hand side, sorry, I don't know if I messed up the left right there. I can't remember what I said. The left-hand side gets wiped out and becomes 0. The right-hand side is 6x squared minus 19x plus 10. Okay, so the a value is 6, b value is negative 19, c value is 10. So from here, I'm going to plug into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just plugging in these numbers every time their respective letter comes up. Okay, I'm going to do some simplifying now. X equals, that's going to be 19 plus or minus, what is this all simplified to underneath my square root? I'm going to use my calculator, double check. That's going to be 121 all over 12. Well, hey, we got square root of 121 again. We know what that is. We know square root of 121 is going to be 11. Okay, so we probably could have factored this, but it would have been pretty difficult with that a value being 6. So we can go straight into the quadratic formula with this. So let's finish this out. We've got x equals 19 plus 11 all over 12, and x equals 19 minus 11 all over 12. So once I simplify this, this is going to give me 30 divided by 12. I can simplify that fraction and get 5 halves, or 2.5. And then my second one, 19 minus 11 divided by 12, is going to give me 8 twelfths, which is going to simplify to give me 2/3, or 0.6 repeating. I usually stick with the fraction answers, not the decimals, but wanted to show you that both are allowed. All right? So that is how to use the quadratic formula. I highly encourage you to factor if possible, but if it's too difficult, the quadratic you're dealing with is too difficult, you have this quadratic formula. You just have to make sure you memorize it and know how to use it. Have a good one.